All right, in 10.4, we're going to talk about different uses that sound has, whether it's in a concert hall for medical needs, for ships to graph the bottom of the ocean floor, or even animals. So let's get started. The first thing we need to know is the importance of acoustics. So acoustics is basically the study of sound. And when you have good acoustics, you have good sound being produced, you have happy ears. So basically, when you're in a big concert hall, for example, you hear sounds and you hear echoes. So what is echoing sounds is that you hear sounds and their reflections as they hit your ear at different times. The reason that sounds echo is because you have tons of these reflections occurring that are reaching your ears at different times, and they produce something called reverberation. Reverberation is not really a good thing because it can actually ruin the sound of music. So when you go to these big concert halls, they usually have, like orchestras and things like that, they actually have lots and lots of curtains that are hanging at the top and around the area, because the curtains actually help to reduce reverberation. And, it also, when people are going to perform at concert halls, they have to look at the size of it, the shape of it, the furnishings that make up the room, and how that can affect the sound that is going to be produced on stage. And it depends on how big big the orchestra is, because if it's too small, it might not sound as good as something that's a little bit bigger. So people who study acoustics, they have come to know that if you have soft, porous material like curtains, they actually help to reduce reverberation. And so really thick curtains are used a lot of times in concert halls. Not only do they look beautiful, but they are actually serving a really good purpose for reducing the reverberations that we would hear from the echoes. Now, another term that is really interesting and fun to learn about is called echolocation. You might have heard of echolocation with certain animals like dolphins. Today we're going to specifically talk about bats. So bats use echolocation, and they actually depend on echolocation for a way to locate objects. And the way they do it is that they emit sounds, and then when the sound waves return back to them, being reflected off of certain objects in their way, they are able to decipher and interpret that sound to base off of what might be in their way, how close is it, how far is it. So bats can actually use echolocation, and they move this way and are able to fly in the dark without hitting anything, and they can go hunting for bugs and know how close the bug is, all by using echolocation, which is absolutely remarkable. So, like I said, bats and dolphins, they navigate and they can locate their prey by using echolocation. So they will, kind of send out that's pretty much how they see, that's their eyes. They send out some sort of sound from themselves. It will form some kind of waves of sound until it reaches an object, and it will reflect back. And then depending on that, they can tell how far another fish is or another bug is. And scientists have recently found that there are certain moths that fly around at night, or in the, daytime too, that are able to block a bat's echolocation by emitting their own sounds, and kind of throw the bat in confusion, so the bat can't tell where the moth is, and the moth is safe from being eaten, which is pretty cool and advanced if you're asking me. So here's an example diagram of what a bat is using as its echolocation. So you have a bat here. It's sending out sound waves that you can see in these red lines. These are the echolocation sound waves we're talking about. And it hits a moth. This moth is flying in the night sky, and poor moth has the sound waves from the bat hit it, and it reflects back in these blue waves back to the bat. The bat can then determine where the moth is, and how far it is based on the sound waves that are reflected back from the moth. And then the bat will continue to, release these sound waves until it has captured the moth and had a scrumptious dinner or breakfast or snack. Another way that sounds can be used is something called sonar. So basically, sonar is a system that is using a reflection in underwater. So they send sound waves underwater to see what is, on the bottom of the ocean, or what is, could be in the way between the top and the bottom of the ocean or body of water. So how this happens is, one, they will send a sound pulse that will be released to the bottom of the ocean. Two, the second step is that the sound will travel through the water, and then it will hit something, and then it will reflect back after it has hit something solid, and they are able to read that sound wave that's being reflected back and decipher what it is. There's something called a hydrophone, which is basically a microphone that they use underwater that can pick up the reflected signal that was first sent out from whatever device that they're using to send signals underwater. And basically, because the speed of sound in water is a constant, it's something that we already know, we can actually calculate the distance that the object that is reflecting the sound in the water, how far it is from the ship or whatever you're measuring it from, based on how much time it takes for the sound to be reflected back from when it was sent out and was captured by the hydrophone. So it's really cool that they can use sonar for something like that. So this is just a picture kind of to show you what that looks like. So you have some kind of ship, usually when you have scientists studying things like shipwrecks or treasure, or, just trying to map out the bottom of the ocean. They will go out on pretty techy looking ships that carries all these devices. So you will have some kind of device that will send out a sonar signal. It will go through the water and say that there's a wreckage or something like that. It will hit that wreckage, and it will emit a reflection of a sound back to the hydrophone, which I said is the sensitive microphone that is used. So since we know the speed of sound in water, this is already known. We just have to calculate the time it takes between the sonar signal being emitted and the sonar signal being collected by the hydrophone. And then you can tell, so the speed in water plus the time it took for the reflection signal to get back from the time it was emitted will tell you the distance of how far the wreckage is underwater. So why is sonar important? Why do we need to use sonar? One, it can help avoid icebergs. You can see if there's submarines underwater, which can be helpful for, during the times of war, or it can just be for safety. You can find different species of fish, or it can help fishermen find fish so they know where to go to fish for them. And like I said, it can help to map the ocean floor rather than having people down there looking at the ocean floor. You can use sonar to send signals and create a map of the ocean. Just as a little bit of a background before we start in this slide, the sonar was actually first used when a ship called SS Central America disappeared by a hurricane in South Carolina, and it had 10 tons of newly minted gold coins and bars. So the ship and the treasure was at the bottom of the ocean till 1988, when they used this sonar technology to locate where it was. And they located about 2,400 meters below water. And they found over 100 million of that gold coins, which is pretty crazy. So most sonar systems, they are ultrasonic. You can also use them in ultrasound. They usually emit sounds with a frequency that have about 20,000 hertz. So you can't really hear them just by human ears, which is pretty cool. So the ultrasound, this is what we use when you are pregnant. So I have an ultrasound, first couple weeks of my pregnancy to make sure the baby's developing good. You can have an ultrasound if you have some kind of pain or some kind of issue with your organs. So this is used in the medical field a ton of times. The sonar that, like I said, is used in ultrasound uses about 20,000 hertz of frequency, so you can't hear it just by our ears. So speaking of ultrasounds, like I said, it is used in medicine. This is when you are examining your internal body organs or parts. So if you have something wrong with your kidney, your liver, if there's an unusual like bump or something, they'll probably have you go through an ultrasound to see if they can find out what exactly is going on. Sound waves, how it usually works for an ultrasound is that sound waves will reflect off of the targeted area. So if it's like an organ or something like a bulge or, some kind of abyss or something, and it will be reflected, and the reflected waves that is from that object will produce an electronic signal that will then get converted into some kind of image on your computer, or whatever device you're using, and those images that is being created by these electronic signals are called your sonograms. And this is a sonogram is usually also how you see baby images. So I have a ton of sonograms at my house that show what my baby looks like. So ultrasonic imaging is a lot safer than x-rays because, and that's why we use it when you look at babies. And so when you do, look at a baby being developed in a woman, you are directing the ultrasonic waves into the woman's uterus, which is where the baby is located, to form an image of the fetus, which is the baby. And so this way you can safely see how the baby is developing, if there's any issues, so on and so forth. You can also use ultrasounds in medicine to treat kidney stones. So you don't actually have to do surgery. You can do a non-surgical method. So what happens is bursts of ultrasound create vibrations that will actually cause the stones inside of your kidney to break into smaller pieces, and then usually these pieces will then pass out in your urine. So kidney stones are produced, can be pretty large at times and very, very painful to pass, especially if you're a guy. So what happens is if you have very large kidney stones, one way they will do is to use ultrasounds, causing the vibrations from the ultrasounds to break apart those stones so that you can try to pass it on your own. If you can't, they will have to use surgery to get it out. Kidney stones can be, it can be something that people can get kidney stones over and over again, which is really sad. A lot of people can develop kidney stones once or twice in their life. This is why it's really important that you stay hydrated. Dehydration can sometimes cause kidney stones to develop. And let me tell you, they're very painful. Thankfully, by God's grace, I have not had any, but I know plenty of people who've had kidney stones, and they say it's like going into labor almost. It's very, very hard, especially if you're trying to pass it through your urine. And kidney stones actually look like super spiky little like rock solid things. So imagine this super spiky thing that's coming down your bladder, which has little like vessels that are very tiny and flexible. So if you have this spiky thing that's trying to come through your bladder, imagine how painful that is as it exits your body. Not fun. So what is the name of the method used to find objects that are underwater? What do you guys think? Is it a sonogram? Is it an ultrasonic bath? Is it a sonar or percussion? If you say sonar, you are absolutely correct. And that is it for our section 10.4. If you have any questions, you can refer to your textbook or you can rewatch the parts that you need. If you need to go back and finish copying your notes, make sure you do. And I will see you guys in the next chapter.